Black Duck Hub helps security and development teams quickly identify and mitigate open source related risks across their application portfolio. You can use Black Duck Hub to scan your code to identify specific open source in use, automatically map the open source to known vulnerabilities, and prioritize and track the remediation of problem components. Hub also identifies the open source licenses in use and whether or not they conflict with your overall application licensing goals. Security starts with visibility, and open source visibility is critical as it's the foundation of modern application development. While static analysis solutions focus on uncovering coding-related vulnerabilities introduced by developers, these solutions only catch a small percentage of open source vulnerabilities reported over time. Open source vulnerabilities like Heartbleed, Shellshock, Poodle, and Ghost have highlighted the level of exposure that commonly used components can cause. The Hub is essentially made up of three components: the scan engine, which when pointed at your applications and Docker containers performs the analysis, the Black Duck Hub server, where the results are stored and viewed, and the Black Duck knowledge base, which works with the Hub server to identify open source matches. Scans can be performed on an ad hoc basis using the Black Duck Hub scan client, which can be invoked at a command line or by using an available graphical user interface. Scanning can also be invoked as a plugin from within a continuous integration build process to allow for automated open source discovery. Regardless of when and where it's invoked, Black Duck uses a multi-pronged approach to identify open source. Information and evidence from both file and folder level contextual analysis, as well as package manager manifest files, are used to spotlight open source in your code, as well as the transitive dependencies that are brought in during the build process. Although invoking Black Duck at build time is the recommended method, Black Duck analysis can also be triggered earlier in the SDLC to spotlight vulnerable open source even before it gets into the application. Developers can use available plugins to IDEs like Eclipse and Visual Studio to help them make informed decisions about what open source they use. For organizations who do not operate a centralized build environment or perhaps develop applications in a distributed fashion, Black Duck can also be configured to scan the build output in a binary artifact repository like Artifactory or Nexus. The Black Duck knowledge base is the industry's most comprehensive database of open source project and security information. For over 10 years, Black Duck has retrieved and archived information on open source projects and downloadable code. Timely updated information is critical, so we continuously update it with thousands of new projects on a regular basis. This includes both weekly open source project updates and hourly vulnerability updates. Your Hub server is in constant communication with the knowledge base, making you aware of new threats as they arise. Even if you've built and shipped your code, you must remain vigilant to changes in the risk of open source components you've used. Let's see how easy it is to start scanning applications with Black Duck Hub and how to review the open source identification results. We'll launch the Hub scanner and point it to some sample code and fill in parameters like Hub project name and version. We can optionally choose to exclude some file types while scanning to minimize scan time. In this example, we'll send the results directly to our Hub server, but if needed, the offline mode option instructs the scanner tool to create a JSON formatted scan results file that I could manually upload. This is useful if the Hub server is inaccessible from where the scanning is occurring. When the scan is complete, we can view the results in the Black Duck Hub web interface. Hub supports multiple authentication options. User accounts can be managed from within the Hub UI itself by an administrator, or you can leverage the available LDAP or single sign-on integrations to streamline the management of accounts. After logging in, we may first see the summary dashboard, perfect for security personnel and other executives. It provides an aggregate roll-up of project security risk, highlights top policy violations and top components with security risk, as well as shows overall Hub usage statistics. The Projects tab provides finer details regarding the risk associated with each of my Hub projects, which normally equate to applications or application modules that I've previously scanned. Hub spotlights 3 dimensions of risk for your projects and the components that make them up. The risk bars help you assess how much of each type of risk is present. The available options on the left let you easily sort and filter the results to focus your attention on the projects that require immediate attention. Let's now drill into a single project and version. Here we see its bill of materials, which is the inventory of the open source identified. We can now see the risk contributed by each component found. Security risk is a measurement of the risk from the known vulnerabilities associated with the component itself. Black Duck maps the open source it finds with its common vulnerabilities and exposure number, as reported in the National Vulnerabilities Database, or NVD, which is maintained by the National Institute of Standards and Technology. Above and beyond that, Black Duck offers a premium enhanced vulnerability data service curated by our dedicated security research team. It provides information on roughly 30% more vulnerabilities than the NVD, and does so on average 3 weeks earlier than the NVD. License risk is a measurement of any conflicts between the license family declared by the open source component, the usage type of the component, and the type of distribution for the project. For instance, if you're planning on externally distributing your project for commercial use, and you're using a component with reciprocal license obligations like the GNU General Public License, it would be flagged as having a high license risk. Whereas another component which uses a permissive license type like MIT would show no license risk. Operational risk encompasses a combination of factors to measure the health of the open source community behind that component, including the number of contributors, the level of commit activity, and the number of newer versions of the component that are available when compared to the one currently in use. As we saw before, column headers can be used to sort the presented information, and filters can be applied to only show, for instance, high license risk components. Let's navigate to another project that was scanned not by the Hub Scanner tool we saw earlier, but instead as part of a continuous integration software build process. When scanning this way using the Black Duck Hub Detect integration, we can leverage a combination of identification techniques, including contextual file and folder analysis, as well as dependency analysis via Package Manager manifest files. The match type column is significant now as it highlights which technique was responsible for the match. In some cases, you may see multiple match types listed, which should give you the utmost confidence that the match is accurate. If we navigate to the Security tab, we can now see the specific vulnerabilities noted against each of our components. As you're reviewing your bill of materials, you may ask yourself, how do I begin to resolve some of the vulnerabilities that Black Duck Hub has spotlighted? With Hub version 4.0, we've introduced some guidance to help answer that question. For any vulnerable component, the Hub displays 3 possible update options. The first option is the next version that fixes the vulnerabilities found in the version you've used. The next option highlights the next version of the component that does not have any reported vulnerabilities. The last option shows the most current version of the component by release date with again no known vulnerabilities. You can also click on the component name to see a visual representation of the security risk over time and version. This information should minimize the cumbersome effort of performing your own research and tracking of vulnerabilities of a given component. It's important to note that not only will Black Duck Hub highlight open source risk in your projects as you scan them, but it will continuously monitor your applications and alert you when new vulnerabilities arise that affect you. The landscape of open source is ever changing, and just because an open source component is safe to use today doesn't mean that it will always be. If a new vulnerability is disclosed against a component you're using, you can use the notifications panel to be made aware of it. Policy management is an automated way to flag risky components and bring attention to them. Let's enable a few Hub policies and see what results. Here we'll enable one policy which will flag components with high severity vulnerabilities, and another to flag externally distributed projects that use reciprocal license types. If we return to the dashboard, we can see several projects have been flagged. Navigating to the bill of materials, we see which components were responsible for violating the policy. Clicking on the violation icon shows which policy was violated. Depending on how it was configured and our own user permissions, we may also have the ability to override the violation. Let's say we've done this. We can inform other Hub users of our activity by marking the component as being reviewed and adding a note using the comment feature. Project users can use comments to communicate back and forth regarding any bill of materials editing that occurs and the rationale behind it. Policy management can become especially powerful when used within the context of a continuous integration build process. It's possible to both perform a Black Duck scan and, if violations are present, fail the build and use the CI tool to notify key stakeholders and kickstart the remediation process. Black Duck Hub offers a variety of global and project-specific vulnerability and licensing reports. The first is a vulnerability-centric report. The results are in the form of a set of CSV files. Looking at the security file shows us the type of information we can mine. It includes metadata like component names, descriptions, vulnerability scores, and risk measurements. The second report type is a notices file, which can be used as the basis for your project's license attribution report. It's a complete list of the open source you're using along with the respective licenses and complete license text. Report information can also be extracted via third-party reporting and visualization tools by using either the Hub API or via a new feature in Hub 4.0, the Hub Report Database. We hope this demo has been helpful in showing you the value of Black Duck Hub. Only Black Duck provides the most comprehensive language coverage and development tools integrations, the industry's most complete open source software knowledge base, as well as integrated remediation tracking and policy management.